Hey guys, welcome to 12.2. We're going to be talking about multiplying matrices using both scalar multiplication and matrix multiplication. So first of all, let's talk about what those things are. So scalar, we don't know, a scalar is just a number, just a magnitude. So the example up here would be speed versus velocity. Speed is a scalar. It's just a magnitude. How fast are you going, right? Velocity is a vector. It has a magnitude and a direction. So it's not only how fast you're going, but also in what direction you're going, that speed. So a scalar really is just a fancy way of saying it's just a number. It doesn't have a direction or anything else attached to it. It's not a matrix. It's just a number. That's what a scalar is. So we're going to be doing scalar multiplication and we're going to be doing matrix multiplication, which is just multiplying two matrices together. So we're going to do multiplying by just a number, and then we're also going to do multiplying by a matrix. So looking at that, so we are just going to be, this is basically what I just explained on the last slide. So when we're multiplying by a scalar, say we're multiplying this matrix, matrix A, by scalar C, so that could be any number, where all we have to do that is just multiply each element in the matrix by C. So for example, if I want to multiply this matrix by 3, I'm just going to multiply each thing by 3. So I'm going to have 3 times 8, which is 24. I'm going to have 3 times A, which is just 3A. So I'm just multiplying that A by 3. And then if I multiply 3 by 12, I'm going to get 36. 3 times B is just 3B. 3 times negative 20 is negative 60. 3 times C is 3C. So like I said, you're literally just multiplying everything in the matrix by the scalar. So let's look at a couple more examples of that. Oh, it didn't go away. I feel like it usually goes away. I don't remember. Anyway, all right. So here, again, we're multiplying by 3. So we're just going to multiply everything by 3. So this is just going to be 6 times 3 is 18. 5 times 3 is 15. 2 times 3 is 6. Next row, negative 4 times 3 is negative 12. 0 times 3 is 0. 1 times 3 is 3. So that's really all there is to it. You're just multiplying everything in the matrix by the scalar. So let's look at this one because this one's a little bit different. Here we have expressions instead of just numbers. So remember that when you're multiplying this, what you're doing is negative 2 times v plus 4 and negative 2 times 4 plus u. So we have to distribute the negative 2 because these aren't separate elements, right? This expression is one element. So we're multiplying the negative 2 by that whole thing. So we have to distribute. So the answer, sorry, let me put my brackets in. The answer would be negative 2v minus 8. That would be one element. And then the other element is negative 8 minus 2u. Okay. So if there are multiple terms in the element, then you have to distribute to both of them, right? So this would be our final answer. In this one, we have a variable in the scalar that we're multiplying by. That's fine. It doesn't really change anything. You're still just going to multiply everything by 5x. So you'd have negative 6 times 5 is negative 30. So you're going to have negative 30x squared, right? Because they both have x's. And then you'd have 5xy, negative 10x squared, and then negative 15x squared. Oh, and this is a good example of why I usually write the brackets last, because I tend to make them too short. So I usually write my numbers and then I write the bracket at the end so that I know what size it needs to be. Because at the beginning, I usually tend to underestimate and I make it too short. So that's just something that I do that could be useful. I don't know. All right, so that's scalar multiplication. So let's do one more thing with scalar multiplication before we move on to matrix multiplication. So in this slide, we're going to solve using scalar multiplication. So just like we solved using addition and subtraction in the last section, we can also solve using multiplication. So here we want x, right? But x is being multiplied by 4. So if I divide both sides by 4, right? Or here, that would be the same as multiplying by 1/4, right? I can multiply by 1/4. It's the same thing. And then I will have x on this side. So I'll have x equals, and then I just have to divide everything in here by 4. So that's just 0. Negative 4 divided by 4 is negative 1. 8 divided by 4 is 2. So that would be my answer there. Now here we have both steps from what we did back in 12.1 and then what we're doing here in 12.2. So we need to add this matrix to the other side, right? Because it's being subtracted. So we need to add this matrix to the other side and then divide by 4 here. So adding the matrix, we're going to add negative 4, 10, 7, negative 1. Sorry, it's not lined up. So we'll have 4x equals, that's supposed to be a capital X, whoopsie. 4 minus 4 is 0. 26 plus 10 is 36. 21 plus 7 is 28. And 25 minus 1 is 24. So now I just divide both sides by 4. So I'm just going to divide everything in here by 4. So I have I'm just going to write it up here. This is going to be, well, 0 divided by 4 is, of course, 0. 36 divided by 4 is 9. 28 divided by 4 is 7. 24 divided by 4 is 6. And so that is going to be my final answer. That's x. Right. Note one thing really quickly, that this matrix is not the same as this matrix. So make sure that you're writing it in the correct direction, because this is not the same thing as this. And we'll see kind of why they're different in the next part where we're doing matrix multiplication. But these things are not the same, so don't treat them as the same thing, or don't switch the orientation of your matrix in the middle of a problem. That's not good. We don't want to do that. So this would be the answer for this one. Okay, hopefully that helps, and I will see you guys in the next video.